Hello, everyone. I am Shamek Balsak, your host for today's Streaming to AI event, and I will help facilitate it. This event is Amazing Race for Free, investigating AI's capability to solve course assignments by Melkior Ornik and Max Fowler. Melkior Ornik is an assistant professor with the Department of Aerospace Engineering at the University of Illinois. He received a PhD in electrical and computer engineering from the University of Toronto in 2017. In the context of education, he's interested in exploring the impact of generative artificial intelligence on the post-secondary enterprise. He's the principal investigator of the effort Artificially Successful, investigating and responding to generative AI's capability to solve course assignments, supported by the Strategic Instructional Innovations Program at the University of Illinois Urbana-Champaign's Granger College of Engineering. His technical research interests include developing theory and algorithms for learning and planning of autonomous systems operating in uncertain, complex, and changing environments, as well as in scenarios where only limited knowledge of the system is available. And Max Fowler is a teaching assistant professor in the Siebel School of Computing and Data Science. He received his PhD in computer science from the University of Illinois in 2024 and liked his time enough to stay. Max currently teaches CS 101, Granger Engineering's large introductory Python course for most of the engineering majors on campus. Much of Max's research is in the space of skills and assessment, specifically identifying the core competencies of programming and, increasingly, skills for working with Gen AI, while developing strategies for fair, secure assessment at scale. His work in this space includes leveraging Gen AI for auto-grading and feedback provision, intersecting with LLM as judge methodologies. Max is also active in several AI-related education initiatives. Among others, he is a team member on Melkior Ornik's Strategic Instructional Innovations Program project, which I already mentioned, and Max serves on the Siebel School's AI Credentials Task Force. And in this presentation will talk about the following. In an extreme challenge to our educational mission, instructors are concerned and in some anecdotal cases already convinced that students are simply using Gen AI to produce all their course deliverables and that no learning is actually taking place. In this talk, we will report on our efforts to test this hypothesis. Is it possible to excel in a course without absolutely any knowledge? We show that while there is variability across courses and assignment types, large language models are indeed often able to achieve a strong grade in a course without any meaningful help from human users or course material. This finding naturally brings up questions about our future assessment methods and even about the value of the material that we are teaching. While obviously yet unresolved, we will describe some possible ways forward at the end of the talk. If you have any specific questions throughout this event tonight, do not hesitate to place them in the chat. And the online chat host will collect them and notify the presenter. The thumbs up on your message or question will be used to confirm your question was received by the host. If you are physically present in the room, obviously just raise your arm and your question will be addressed. Without any further ado now, Doctors Ornik and Fowler. Thank you.
Thank you so much for the introduction. It's a pleasure to be here. It's an honor to speak at any of CITL's events. Since I came to Illinois in 2019, I've been impressed by the efforts that CITL has put into making one of our kind of core missions, education, as best as good as it can be. Partly due to CITL's efforts, I think that the idea of this project kind of came to be. So, as mentioned, my name is Melkior. I'm an assistant professor in aerospace engineering, and I'll be giving the first part of this talk, Amazing Grades for Free. And this will actually be probably a slightly shorter part of the talk, and then my colleague Max will will talk to us in the second part about giving amazing grades for cheap. So we're kind of duals to each other here. So my first part is really about talking about AI's capability to solve course assignments. And what I mean by that is, hey, ChatGPT. I think that I gave some versions of this slide probably a year ago or more, and it was like, yeah, the students try to use AI in their courses, and I said anecdotally yes, because a few colleagues said, oh yeah, I think a lot of people are using ChatGPT. I think that at this point we've kind of gone past I think stage, and it is obvious empirically, anecdotally, that yes, many students will try to use AI in their courses to the greatest extent possible. And so the question that I'm really interested in within this talk and within the project that Max and I are involved in is, okay, well, so what? Is first of all, is this a critical challenge to our educational pipeline? In other words, can students now receive good grades without actually having any understanding or any effort to put into the course? And if so, what should we do about that? How can we inform course design and ultimately the choice of the very materials that we are teaching students to remain relevant as an educational institution? I will be mostly talking about this second part. So, can AI result in students receiving good grades without the desired effort or understanding? So, as mentioned, this is an effort that is powered by a previous Granger Engineering GATE and current SIP program project, supported by the Academy for Excellence in Engineering Education, and I have the pleasure of serving as the PI for this project. It's a big project. Jamie from CITL is one of the co-PIs, Abdul Alawini, Max Fowler from CES, Jennifer Cromley from Education, Sikrid Egel from Aerospace, Kaylin Yankee from Technology Entrepreneurship Center, Kelly Halloran from Mechanical Engineering, Binhu, Abhishek Umarwal, and Love Varshney from ECE. And so, given such a big group, really our project is, hey, we're taking a bunch of courses that we are teaching, and that perhaps some of our colleagues are teaching with their permission. We're taking all the deliverables, all the homeworks, midterms, design projects, essays, whatever it is. We're putting them into ChatGPT and we're saying, go solve this. And then we're evaluating its responses as if they were submitted by a student. We're being very explicit about the fact that we are using Gen AI here in a way that models a truly minimum effort student. So not a student that is going to say, hey, can you help me with this? Here are some lecture notes. I don't understand this, things like that. No, we are literally copy pasting the actual homeworks or screenshotting the actual homeworks and saying, okay, now give me the solution. And so the pipeline is really very simple. The course assignment gets created by the instructor. We take that assignment, we put it straight into AI. We then basically copy the output of the AI into an LMS or send it to a human or whatever it is. And that gets graded in most cases by a human or by some sort of an automated grader, in whichever way the course uses their grading. We're prompting exactly the deliverable questions, nothing more, nothing less. We are not trying to rephrase things to make it more potable for AI. This is graded by real graders in as much as possible. So the submission process is careful to not make the study obvious in some sense. We are evaluating a variety of fundamentally different courses, all broadly within the engineering framework, but from kind of mathematical courses to courses that are programming heavy to courses that are kind of outliers, whether it is the entrepreneurship course, TE 100, or a computer-aided design course, ME 170. We try to make our data as rigorously collected as possible. Every question, every prompt, every generated answer is available for possible longitudinal analysis later. Importantly to point out, we are not using any student data. We are not
interacting in any way with students. We are solving the same homeworks that the students are solving, but we are not accessing any of the student data or information. Ultimately, a meta goal of our project is to create a pipeline, to create a know-how and well-documented policies that we can use for future courses and enable people to join this effort in some sense, whether kind of really with us or just in spirit, kind of picking up on our ideas. In terms of the initial results, and we are now, let's say, halfway through the project, but I'll only be presenting some results from our pilot study, which was back in September. LLM is good, and it is good even in cases where we might not think that it would do great. You might think that project reports, these long pieces of writing are a hurdle. It turns out they're not always, and certainly in the course that I was teaching, it wasn't like that. You might think that essays, less technical pieces of writing are a hurdle to AI. That also turns out not to always be the case. In TE 100, they had some of those. You might think that using custom tools for teaching, for assessment is a hurdle to AI. That's also not always the case. And we're kind of increasingly seeing that even things that we would think that AI would have no chance at doing in ME 170, it sometimes can. And so I spoke to a bunch of colleagues that say, oh, yeah, this is a big concern, but this is not a big concern for me, right? My course is AI proof. And likely it is not. Of course, I'm not saying that it is perfect. We see some differences. It gets near ceiling performance on kind of algorithm design, multiple choice questions. On the other hand, on something we call conceptual analysis, it's somewhat less than perfect, but it's always good. And when I say somewhat less than perfect, I'll get into that. The numbers are still pretty high. So just to kind of give an example of this case study kind of pipeline that we have. So in EC 313, this is a mathematical course for kind of based around the notion of probability. So a question is given to students. It says, hey, in class we did this, do this, A, B, C. We then take this question, we screenshot the question, we literally paste the screenshot into ChatGPT or Gemini. We say, you're given a screenshot, give me the answer. The LLM provides the answer in LaTeX code because that's, I guess, what was expected from the homework. We generate a PDF, or the LLM generates a PDF, and we grade it. And in this case, it got very, very high grades. So in general, and this is, again, one of the courses, EC 313. So just to kind of give a ballpark of the success of ChatGPT and Gemini. So in homework questions, it got 97 ChatGPT, 95 Gemini. In exam questions, also 95, 96. So this is not perfect, but it's pretty much as close as you can get to perfect. And overall, and so we tried this in a bunch of different courses. ChatGPT and Gemini do well, and we tried also with Claude and with the older versions of ChatGPT, and you can kind of see that there's some small differences. But overall, if differences between different tools or different kinds of problems seem large, I want to point out that these graphs here, they start at 60. So even when it is underperforming, even with the worst tool and the worst kind of questions, it still gets like an 85 or something like that. So in terms of qualitative results, hey, we can see that on our sample, at least, LLMs do very well. This is an early pilot study only. We have an upcoming ASWE paper describing these results. We are working on 8 other courses, 4 in the fall, 4 in the spring, and these numbers are coming in. I want to kind of end partly with limitations. So as concerning this might be to instructors, or as happy of a news this might be to students who don't want to put any effort in, Gen AI doesn't always perform perfectly. Certainly, the most common hurdle appear to be environments which can't be easily understood by generalist tools. So one of the courses that we're looking at, ME 170, relies on a particular piece of software. And the current iterations of ChatGPT have a very limited understanding or ability to kind of replicate or interact with that software. Obviously, human restricted assignments are by definition not replicable by AI, so in class presentations, attendance scores, things like that. Hands-on activities are obviously also not yet directly solvable, although physical intelligence, I guess, is moving forward, but AI can still be very helpful to students there, just perhaps not to the level of we copy-paste the question. For all three of those, again, I want to say this is not, our protocol is very restrictive and it is kind of all or nothing, right? We will copy the question and we'll see if the answer is correct. There are useful uses of AI which might make the student's job much easier, even in cases like these. And we've seen that students are likely much more resourceful than just copy-pasting. The message being, hey, whatever you are teaching, whatever you are doing, AI is likely very good at solving your course problems. Differences still might exist, but it's much easier to become overly confident than underconfident in protecting your questions from AI. And so I think the core question in the future is not how to protect against AI, but rather how to maintain the value of university education in the face of AI. And I kind of identify three mindsets that a lot of us fall into of AI as a tool. So AI being something that I'm going to use all the time in classes versus AI as an enemy, something that I'll try to prohibit, something that I'll try to regulate against. And I think that our project is kind of taking this middle approach of, hey, it's there. And we somehow need to adapt to it. And we cannot, in good faith, just pretend like it does not exist. We've been, just to plug a thing that is marginally related to our SIP project, but it still is, we've been jamming a little bit on the topic of maintaining the value of university education in the face of AI. And so we recently developed still kind of internally this white paper of a vision for STEM higher education in the face of AI, thinking about what are the challenges that we are facing, not just as instructors, but also as researchers, also as designers of whole programs and curricula. Finally, an advertisement, and emphatically, this is an advertisement for literally everyone who may be watching this or may be interested in this, is, hey, if you are interested in a quick indication of how your course is doing, we are in the process of developing in some shape or form something that I'll call an AI diagnostic clinic. Essentially, you come, you bring your deliverables, you bring yourself and or TAs, CAs, whoever you want to operate these things. We tell you roughly what the pipeline is. We tell you what LLM students often use. We tell you what prompts to include. We tell you whether it makes sense to include lecture notes or not. We guide you through the data collection and evaluation pipeline, and that's where we stop. We let you draw your own conclusions. We don't tell you whether this course is good or bad or whether you need to change anything, but you get to consider the impact of your results on your course design. And in whatever shape or form this clinic happens in the future, we're happy to talk right now. So if you're watching this, if this sounds like something that could inform your teaching practices in the future, just send me an email and I would love to talk to you further. And so I'll stop here. If there's questions, I can take them and then we can move to Max.
We have a question online here. Colleen King asks, are these courses creating dummy student Canvas accounts to submit the assignments so graders aren't aware?
Yeah, so it depends on the course. But yes, to some extent, yes. We try not to lie to our graders. On the other hand, we feel like literally telling them, hey, this is an AI generated answer might change their approaches.
And I think this one, Sangeetha's kind of says an indication of how your course is doing in terms of being AI proof, question mark? Or...
Yeah, exactly. I think that we don't, we want you to draw your own conclusions in the sense that if you want to have your course be AI proof, great. On the other hand, if you are aware of the fact that your students might be using AI and you are fine with seeing that, hey, this is why they might be getting 90s, and I'm not saying this is a bad thing at all, then yeah, that's also fine.
I got a question. So where does identifying and like academic integrity and academic dishonesty like fall into your framework of understanding?
Yeah. So this is a very good question. My answer is very simple. It does not anywhere in the sense that, so right now we are not interested in identifying who might be cheating or using AI tools in any way that's prohibited. There are folks who are interested in that. And I think this is a very interesting thing, but I think that to a large extent, this it kind of boils down to an arms race, right? Okay, when we will figure out what students are using AI, then the students might come out with a better AI, and then we're constantly in that. And to some extent, that's why I think we feel that a blanket ban on AI is a hard thing to implement.
I think if I can riff on the white paper that Melkior teased, I think this is the value of designing courses and assessments to get trusted and validated signals rather than designing every assignment to prevent AI. So, computer-based testing facility, assessments that can only be done in class, oral examination. There are ways to get to pieces of summative assessment you can trust, and those are sort of the better bang for your buck than trying to blanket ban AI.
Okay, Max, I'll switch with you. I have you at one. Oh, okay. Here's your.
Oh, I have a thing.
You have your thing.
Okay. So Melchior gave you or talked about amazing grades for free on the student end. I'm here to talk a bit about the AI as a tool piece on how we can leverage it to give amazing grades for cheap. And particularly, it's in the context of AI and LLMs being remarkably good at constrained rubric tasks. So roughly in the space of automatic short answer grading, I'm not going to talk about like big essays today, although that's a related thing, but sticking within small natural language responses and other rubric tasks, how can LLMs serve us? And actually, the context of this predates natural or LLMs. It goes to more like natural language processing and classical AI, in that in computer science, there's this type of question called an explain in plain English question. You give students a piece of code, you ask them for a high-level English language description, kind of like you would talk to someone about it. You don't need implementation level details. And then you give students feedback on that. Did you reach a high level of abstraction? Are you technically accurate? And are you not too focused on implementation level details? Now, this is naturally hard to grade. You could have 3 different answers. Whether they're all good or not, whether they're equivalently good, that comes down to something of a subjective standard. And additionally, if the grading is manual, it's very difficult to scale. I regularly teach courses with 500 to 900 people. I also use the computer-based testing facility. So if I want to use these on exams, then I have to get like different versions of questions for different students. This is a grading burden that requires, if you're doing it manually, a fleet of TAs, a fleet of human time. And we had solved this problem in a way previously with old style AI, natural language processing. And for doing that, you just label a whole bunch of answers. You discuss those labels with another coder, come to a rough establishment of ground truth. You fit some kind of model, and then you use that model to grade. And so a basic approach to this would be given some answer, you do some pre-processing, you stem it, you get rid of some filler words, you turn it into some representation. In this case, we actually used a very simple bag of words and a very simple logistic regression. That is not a complicated statistical method. and it tells you whether or not the student's answer is roughly aligned with the previous things that you saw labeled correct or incorrect. One thing I wanted to raise here as well is that in this solved problem, we hadn't solved the question of feedback. This was just static feedback. Oh, if you got the answer wrong, here's some examples. Maybe for a complicated piece, here's a diagram, but we weren't giving individualized feedback at this stage. As far as ground truth, me and a colleague went through, I'm gonna say it was 3,000 or 6,000 answers at this time, achieved an agreement of 0.83 cones capital, quite substantial agreement. We tested this on students' answers from CBTF exams in fall 2019 and spring 2020. And then the fun thing about this is we also compared the model versus two groups of TAs. The confident, slightly purple TAs we trained, gave them roughly like a 30-minute training session and then set them to grade. The question mark TAs, we gave 5-minute overview of, hey, here's how you upload the grades to Prairie Learn, have fun. And to sort of let them to their own devices. They knew high-level communication was the goal, but that's basically all they knew. And even with a non-sophisticated machine learning approach, the model is about as good as the average TA. So already with natural language processing, you were hitting mid to high 80s. You pull a TA off the street, you're going to hit mid to high 80s. Training maybe helps a little bit, but not always. And then you think, okay, maybe I don't need LLMs for this. But we had thousands of labeled student answers. And while my colleague and I can label thousands of student answers now, maybe in 20 minutes to an hour, because we've been doing this for a long time, any arbitrary TA you assign, that's a days-long task. LLMs can perform these rubric tasks with much less information, at orders of magnitude small. You can give them some persona as a context. You can give them the piece of code and the same assumptions, so the same things we give the TA. And then rather than thousands of examples, we can do 3. We tried 5. We tried everything from 1 to 5. 1 is too few, but anywhere from 2 to 5 is perfectly fine. 3 right answers, 3 wrong answers, a student response, grade it. And we've run a few different versions of this. This one is just the grade it yes or no. There's one where it's like grade it and give feedback. And we'll focus on a couple of results from those two as we go. As far as the data set, it's the same set of questions, but they're new student responses. So we had 3,064 student responses from spring 20 to 22. In part, we grabbed the newer semesters because spring 20, COVID era. Do we know if we can trust that for sure? So we wanted to have more data. And we tested 2 types of LLMs. We tested proprietary models, which at the time of this work, GPT-04 Mini was the best one. And then the day after we got the acceptance on one of the papers, GPT-5 came out. So already out of date. But we tested on a fleet of GPT-4s, and then also a fleet of open source models. In part from a question of local deployability, in part for a question of model size. You'll notice some of the open source models are much smaller. So if you're a resource constrained environment, is a small open source model good enough? If you're concerned about security and data privacy, you can use an open source model. Even just consistency and sort of provenance there. If you're running an open source model, OpenAI can't decide your GPT is going tomorrow. As far as the evaluation pipeline, it's very similar to the evaluation from the NLP. We set aside a chunk of the data as a test set, ran it through the prompts, and then just compared it to the ground truth that we had previously established. Quick results highlight. I put the NLP approach up at the top as a comparison point. NLP, about as good as an average TA. GPT-04 Mini, about as good as an average TA. Llama 3.1, about as good as an average TA. And in fact, if you compare Llama to GPT-4o, Llama was slightly better. And some of the other smaller models were at least not statistically significantly different, even though the accuracy is perhaps a little bit worse in raw numbers. When you're talking about thousands of student answers, no difference noticed and not that different from a TA. Even if we compare 04 Mini as sort of the gold standard at the time, it's like, oh, this was the best proprietary model. Llama's not statistically significantly different. And if you're in a resource constrained environment, let's say you really only want an 8B model, okay, you trade 4 pieces of accuracy for a very small model. If your institution only has a small server, that might be a worthy trade for being able to grade these at scale. So cool. LLMs can in fact autograde EIP. And I'm going to say constrained automatic short answer grading in general, likely as well, with roughly human TA accuracy. Maybe not the mid-90s that we would expect from our best TAs, but good enough for the average TA. But that raises a question: what do students think about it? Some of us really don't like when students submit AI. What do students think when AI is part of their grading pipeline? So we ran another study, and this was part what do students think about AI grading, and part checking the impact of transparency. And I promised you a version of the model that gives actual feedback. So similar prompt. The difference here, rather than yes or no, it also included, oh, give some feedback to guide them along. But otherwise, it's the same kind of question, piece of code, students give an answer. And it's a little hard, I think, for folks in the room to see, but the bottom of the question has information on transparency. So this reads, this autograder was tested on 70 student submissions. So this particular question had 70 and achieved a 96% accuracy versus ground truth. Sometimes the autograder is wrong, so feel free to reword your answer and try again. And that was it. The study had a control condition where they didn't get that transparency and a treatment condition where they did get that transparency. And it was an extra credit assignment in CS 105. Half of them had the transparency, half of them had the exact same questions, exact same model, but it had no blur. It was just, hey, this is graded with an autograder. Note this is in contrast to the old form of NLP, and I raised that because I used the natural language processing grader in that class already, but for this extra credit, they got access to this LLM grader. And I think that context is important because and then we asked several questions, but the only two where we noticed a difference between treatment and control is that the transparency students thought the feedback was a little more accurate. And so there's a degree to which just being told, this is how good the model is like, okay, I believe you, probably it's accurate. The second one here was not significant, it was marginally not significant. It was a 0.08, I believe, for the p-value, in finding the feedback helpful. So there's perhaps, and with more students, maybe we would have gotten a signal on transparency making students feel like they're learning more. And I mentioned there are several questions we asked that I don't include here. Questions included, oh, do you trust the grader? Very high. Yes, I trust the grader. Do you like this better than natural language processing? Yes, I really like the personalized feedback. For time, I didn't include student commentary, but we also had some open-ended comments from students. Same kind of idea. I love the personalized feedback. It helps me realize specifically what I can fix. The negatives really focused on sometimes it's picky, which I'm also picky. So in that way, the model is doing what I want it to do, which was actually, I think, quite surprising, this high level of positivity, both in terms of liking the grader, liking the feedback, and being comfortable with its use, both homework and exams. Homework higher than exams, but majority was like, yeah, it could be put on an exam. It'd be good if I could get my instructor, the key piece is get the instructor to double check if I think the model's wrong. But other than that, generally a positive signal. And I raise that as interesting because that is very different than even just 4 years ago. Ran this 4 years ago with the NLP grader, and the student response was like, not at all. Like, how dare you? How dare you not grade on answer? So the ubiquity of AI is somewhat serving in adoption of these strategies. So, does that mean we should use proprietary models for everything? They're slightly better. They're only going to continue to get better. Probably GPT-5 hits a higher accuracy. Absolutely not. I brought up that notion of security and provenance. I don't like the idea of trusting big companies and third-party providers with my tools, with my pedagogy. Okay, fine. But open source was good. So should we use AI for absolutely everything? Can we just, develop the models, do the testing, set it aside, and then go on vacation because the models we built handle it for us? Absolutely not. I don't think that everything an AI conceivably can do means we should trust them to. I don't know if folks had a chance to read this article when it happened. There was a 13-hour AWS outage caused by a vibe code issue. I believe there was a Microsoft update a couple versions ago that locked a certain set of users outside of their C drives because of a vibe code piece of the update. A major NVIDIA update, which I think is interesting because NVIDIA is big on AI, dropped performance for every game on the market for 3 subsequent versions because they couldn't fix the error. So I would actually say the power of AI necessitates understanding what AI skills are and how to teach and assess them, even more than if you had asked me this question like 3 years ago, I would say, yeah, we need to learn how to teach it. Asking it now, we needed to learn to teach it yesterday. And so I raised this notion of, I live in this world of programming skills. So going back to that introduction, I'm a skills and assessments researcher. A few years ago, my life was easy. Students trace code, they sequence code, they write code, and then comprehending code and talking about it at a high level seems to be the hardest thing. Now my life is confusing. I think all of our lives are confusing. And the challenge of filling in all of those question marks is the exciting era we live in now. That's what I got. Thanks so much.
So we have plenty of time for questions online too. Nothing's come in yet.
I thought I was going to run low on time, and I've learned I have a tendency to be able to be good at fitting a talk into a shorter time if I think I need to.
When I saw your slides, I was like, okay, I'll do 20 minutes and Max will do 40.
So I'll throw one in. So this is for Max. So grading with AI isn't advisable at this moment. Do you foresee a time when TA will be expendable and AI will take care of all of these grading assignments?
It's an interesting question. Philosophically, I think human validation is always an important part of it. Now, I think we arguably, especially with these kinds of questions, already are at a point where you can have the AI do the grade, and the onus is on the student to be like, hey, I think this was slightly wrong. And then I think you need to communicate to the student, don't be afraid to communicate that and shoot your shot. Students are really bad at knowing when they're wrong. So this isn't in this slide deck, but in work we've done previously looking at can students with the natural language processing grader, can students say correctly, oh, the model marked me wrong? Very, very rarely. The majority of complaints you get are from folks who are definitely wrong. And then unfortunately, also students who are wrong, or rather students who are right and the model was wrong, aren't as good at correctly raising that. So there's a dual issue there, which is why I raised the need to communicate to students, you're not going to bother us, have us take a second look. But I think on a question of scale, let's say you have the AI grader do the first pass, and you tell students, hey, you can complain if you want to. The majority of students will either get the points and not care, or not get the points and be like, oh, okay, I understand why. So, in a course of 900 people, maybe 50 to 100 people ask for a TA to look at it. If you have 12 TAs, you can divide that up between them pretty easily, and then the scale problem is not so bad. So I think on that end, you don't get rid of the TAs. I think also the human interaction piece is important. So there's this notion of LLMs as tutors. And I think LLMs are great, when it's 1 a.m. and your student has no one else to turn to. Teaching them how to use these tools to get some late night tutoring is a useful thing we should do, but it's not going to replace working with people, meeting with people, and that human connection and the human piece to learning.
I think that to students, at least psychologically, I find that it's very important that there's this kind of notion of, the buck stops here, right? That there is some sort of the ultimate decision-making authority who they can talk to, and they can say, hey, man, I really think that I'm right here. And then
this person is somehow qualified to say, "No, you were wrong." So to that extent, I think human verification.
I may pose a follow-up. You mentioned that you should have been teaching AI yesterday. Can you give me an example of it? What are the skills, what are the messages that you should have been teaching our students and ourselves for that matter? What should I know about AI if someone asks me a question about how to teach it?
Absolutely. I'm going to wrap it in thinking about software development because that's sort of the world that I come from. And the tragic thing is this is something that CS has never done that well. But if I think about like teaching debugging and teaching problem decomposition, yesterday we really should have been teaching not just how do you write the solution, but given an opaque box that you give data and it puts out something, how do you design the suite of tests? How do you design the verification to know that this opaque box is performing the way you want it to in a way that you can then stitch it together with other opaque boxes? We don't do a lot of the design thinking. If I think about like a traditional CS program, maybe at the 300 or 400 level, they take a software engineering class, but maybe not all students take a software engineering class. And I think that late in their career is an insufficient point to build this muscle. Part of that is that our mistake as a field was, oh, they're going to write a bunch of code. So they'll learn how to debug and they'll learn how to decompose problems naturally over time. They no longer write code.
I'll ask a question. So I know you kind of gave real world experiences with Amazon. Where do you see the future of AI in terms of teaching learning?
Oh, that's a great question. I'm still figuring out exactly where I see the future myself, because I think so in terms of like the skills that we teach, I know it has to be something, but part of the issue is if I look at industry, they want AI and you ask them what they mean, they say, I don't know. Then you talk to students these days and increasingly it's like, man, I don't like this AI thing. Is it going to take my job? Am I going to get paid? Am I going to get fired if they don't like using AI? And like neither of these views are great. So one of the things we need to do in the near to midterm is define, okay, what are AI skills? And I think it's delineating what's the tedium that you offload to the AI and how do you manage the AI? Because especially if you think of agentic tools, people are now managers all the time. An intro programmer, an intro engineer has their team of very smart, very gullible, slightly sycophantic agents. And wrangling those agents to do things correctly is a skill we need to learn, and we need to learn and then need to teach. I also think there's a question of AI's impact on education. If it reduces, if a person to learn how to program needs to take maybe one introductory programming course and then 2 AI tool courses, and that gets them to the same place where they were in 6 new courses, what does that mean a degree is? Harkening back to the white paper we're working on, I like the notion of, I call them micro-credentials, like a series of micro-credentials. You could think of it as a series of minors, but philosophically returning to sort of the liberal arts education sense is like, oh, you have 4 years and you want to demonstrate mastery in 4 years. What are like 3 or 4 stackable things? You're like, I have my CS, I have my understanding of history, and I have like this business relations piece. And together that gives me this set of skills that I am carrying as a person. So I think it's a chance to increase sort of the individual choices that students can make and increase the amount that they can do well in the 4 years that they're here.
Yeah, there's a question online here. Amelia asks, I might not be following correct, but in your study on transparency, how do you account for students from the control group talking and therefore disclosing the information to students outside of the control group?
That's a great question. Technically there's no control, so that could be a confound. I think the chance of a student discussing in depth an extra credit assignment I should add some context. They had a week to do it. It was on Prairie Learn online at their own time. I think the risk is low. Maybe folks would be like, oh, I did that thing. It was kind of neat that it had a transparency. It was like, what do you mean it had a transparency? But it wouldn't impact. It could impact if someone did the activity, talked to their friend before their friend did the activity. Maybe they'd go in with a slight difference of opinion. But I didn't see any signal in the data or even signal in the more open-ended responses that indicated that students did a lot of crosstalk. Great question.
Well, I'll ask the hard question. Go ahead.
Well, you mentioned agentic AI, and there was some discussion about TA. So I just thought I'd ask: do you see that some of your study is eventually going to evolve into using more agentic and AI to serve as TAs, and see how that how that interaction might affect how those feedbacks are received?
Yeah, I think I am interested in the long run. There's an interesting question of, can a student have an agent that grows alongside them, becomes a knowledge model for them? And you can kind of think like the intelligent tutoring space or knowledge tracing space. Can you have a personalized tutor who grows with you during schooling? I think for automatic short answer grading. So in this particular use case here, agents wouldn't bring much value. It would be using more resources, more time. I'm not sure an agentic tool would get higher than the average TA anyway. So then why am I paying more for similar performance? And even if it did, let's say that I got an agent who was 100% of the time, like matched to what I think. Is that worth it when I could have 92% of the time for cheap, and then occasionally students could tell me to double check something? I think in that case,
especially since there's no guarantee that you're 100%
no, that's true
to start with.
That's true. Yeah, there's 100% versus my ground truth. Any one of you could have a slightly different percentage there, just because I'm fairly strict. I think that percentage, Mariana Silva and some of her students have a version of this that they did. I think their accuracy sits around like 92, 93 normally, just because they're less strict than I am.
That falls in line with what I'm thinking too, because I find like there's been a lot of push towards the agentic stuff, but I keep on thinking like, how is this useful? I like that use case of like, oh, if I have somebody that knows me and goes alongside me, okay, that's something that I can see as useful.
Yeah.
But like, is everyone really going to get one? Like,
no, and not every problem needs an agent. Yeah. So like on the programming end, if you have a team of agents, I can see, okay, you write this piece, you write this piece, you write this piece. Your job is to develop and test that, and then I make sure it's all right when I integrate it. But you don't need agentic tools to help write an essay. You don't need agentic tools to answer a question about a function of code. It's an inappropriate use of those tools.
My question is much harder is, so being the teaching center and getting a lot of faculty who realize, wow, my assignments are not AI proof. I completely agree. There is no such thing as an AI proof assignment. But what do we do for faculty now? How do we help them evolve assessment?
See, this is a great question, and if the college gave us a few $1 million, we would come out with a very strong solution here for you. So, in short, I don't know. I think a part of it is, okay, so we can, to some extent, even at scale, we can modify our way of assessing things to still verify the same questions that we were asking students before to be reasonably certain that they're not using AI, right? And so there's computer-based testing facilities for bigger courses. There's oral exams, in-person exams, things like that. I'm not saying that cheating is entirely impossible, but it reduces it a lot. But I think the other question and the more insidious question there is, do we actually want to be asking the same questions that we did before, right? And so, and this comes to I think exactly what Max was saying in reply to a previous question.
what are these new skills that we might want students to have, right? So I'm teaching a fairly mathematical third-year course in aerospace engineering. My students right now are with AI. They are capable of solving every single question that I used to ask, right? They can get 100% on the midterm, no problem whatsoever. And some part of me says, oh, this is bad, right? This is wrong. This is not how it should be. On the other hand, hey, they have these tools. These tools are out there. And so for a lot of the stuff that I might be teaching them, it's kind of analogous to me trying to teach them to compute trigonometric functions without a calculator, right? We don't really do that. We have a high enough trust right now in the calculators that we're like, okay, apart from very weird, like rare situations, this is going to be fine. And so I think my personal philosophy for this course, and I'm not sure that I would recommend it to everyone, is kind of evolving in the direction of verification. So not so much asking students to perform things from scratch, but rather teaching students or assessing whether the students are able to certify that the answer that they have received or that I give them that used AI is correct, whether they're able to pinpoint, hey, here is the flaw, this is how you would fix the flaw. And they can use AI in fixing the flaw, but it's still going to be them to kind of figure out, okay, this is what's wrong.
So I add one thing to this as well, in addition to verifying and validating something. And I don't know the way to do this, but figuring out a way to assess process at scale. So when you approach a problem, are you taking steps that are good, or are you just you ask GPT, fix this a dozen times, and eventually it works? Because if a principal use of these tools we want to teach, just spending infinite tokens to eventually get a correct answer, I think actually we want to penalize, because that's not learning a good process then. It's offloading the whole process to hoping GPT randomly gives you something that works.
But yeah, I think your question is ultimately it's the holy grail of everything that we're doing essentially. So in our SIP project funded by generously by the department or by the College of Engineering, we're at the end of our first year, right? And so the first year was this data collection, and these results are interesting, but it's kind of straightforward, right? We build this pipeline, we send things to ChatGPT, ChatGPT returns them, we have a nice graph that says it got 98%.
You knew what you were going to find too, right?
Yeah. And then the question that we're facing right now for potential renewal in years 2 or 3 is, and this is I was very much exaggerating, millions of dollars worth, but it's still an effort. What do we do with that right now, right? So I come to an instructor right now and I say, okay, yeah, your course assessments are basically useless. Okay, so how do we fix this? And I think it depends. For some people, it is going to be that they will really say, okay, so I want my students to know how AI does these things, and so they will go deep into the into the algorithms of AI and tell students, okay, this is what's happening behind the scenes. Some instructors might take the kind of middle ground approach of that I'm taking right now, or leaning towards, of kind of, okay, I'll tell you enough to be able to verify these things. Some instructors might say, okay, my job will be to get the students to be the best prompt engineers ever. And so I will teach them exactly how to talk to AI to get the answers that they want. And this is not an insignificant skill, right? To try to phrase things correctly, to use the correct tools for the correct things. And okay, and then this is going to be the contribution to the students' learning. I don't think either of those are.
Silly example of that, but that little robot, the smiling robot, smiling because he's open source, he's an open robot, was generated by Gemini. You would think something that simple would take 1 prompt. It took 3, because I asked for the robot, it gives me the robot with gray and white checkers behind it because that's supposed to be transparent. But they were literally the gray and white checkers. And so I say to Gemini, hey, there's gray and white checkers behind this. Those need to be removed. And Gemini tells me I'm wrong. No, it's just the way it displays. And then I explain, no, Gemini, you literally put them there. I need them gone or I need plain color. It's like, oh, my bad. Let me give you a white background. But it was not a simple diagram was not a one prompt task. It was a 3 prompt task.
And I think that, to the extent that we say, oh, then it might be, it might be enough for all our students to just become prompt engineers. That is not something to be afraid of in some sense, right? If this is what the future, and we don't know yet, but if this is what the future of employment is, and if our job is to prepare students for this future employment, then this is what it is.
And I do like this example. I have never heard of explained in plain English as part of the tradition in computer science. But that's what students need to be able to do about whatever concept it is that they're supposed to be able to write on an exam now. And so yeah, I think there's something to that. How do we surface that without having to do oral exams for everyone?
And I love your comment because you picked up on, this is not something that I've heard about now or before now in the tradition. I think precisely because the cost that used to be associated with it was high. You needed lots of human time for every interaction. Now you can have human time for the subset who need the help on understanding it. And the subset for whom a little bit of working with a grader gets them to the right answer and gets them the understanding, they now have a scalable solution.
Okay. James is asking, any go-to prompts for teaching the chatbots to someone who's never used it?
Oh, jeez. No.
This is now a meta question, right? How do we prompt engineer prompt engineering?
Ask the GPT.
Yeah.
That's all you got to do. What's the best prompt I can ask you?
Yeah, exactly.
So, actually, why not start from a rubric you have? If you're thinking about, oh, I want to use it to increase my grading, you have a rubric. Try to turn your rubric into a prompt and tell it the context of your course and see how it does. And maybe that's a good starting point, because rubrics, it's getting a prompt to do exactly what you want is much the same process of getting a TA who doesn't know what they're doing to do what you want.
Thank you very much. This is great.
Yeah,
it's great.
Thank you for having us.
I gotta run.